Okay, everybody, so now if you have seen part 1, you're ready to look at part 2 for acid chloride reactivity. If you haven't seen part 1, I'm going to leave a link in the description and I would suggest that you go check that out. So part 1 dealt with how do we create acid chlorides from carboxylic acids, and then how can we turn them into the other carboxylic acid derivatives, which included anhydrides, esters, amides, and then going back to the original carboxylic acid. That's what's covered in part 1. Now, in part 2, it turns out because the chlorine is such a good leaving group that we can get additional reactions besides just the creation of the other derivatives from an acid chloride. And to start with, we can do reduction. Now, you should check out, there's other videos on the channel for understanding reduction in general, which is when you're taking ketones or aldehydes most of the time into alcohols. You can also do that with things like esters, carboxylic acids, and acid chlorides, which is why we're going to discuss it here. So, when you get ready to reduce an acid chloride, you have your acid chloride. The stronger oxidized groups, and this would be considered a strong oxidized carbonyl, along with esters, carboxylic acids, etc., you're going to use lithium aluminum hydride for that reduction. So we will use LAH, and then don't forget you will follow up with H3O plus after you are finished your reduction portionality. Now, this is going to occur twice, so you really do want to make sure that you have at least 2 equivalents worth of this compound here. So what's going to occur is that, remember, the lithium aluminum hydride will generate hydrides. So you're going to generate H- in this process. This will come up as a nucleophile and it will add to the carbonyl group. When this occurs, we're going to, just like we saw in part 1, get this classic tetrahedral intermediate. Okay. And then I've added the hydride, and I also have the chlorine here. The chlorine will leave, that's the only decent leaving group in this case, and this will come back down. So what I end up with is an aldehyde. Now, this is an intermediate, and it's a stable intermediate. Aldehydes are a known functional group. However, you cannot isolate this, so this is not isolated in the process. And that's because lithium aluminum hydride is so strong and reactive that as soon as this aldehyde is formed, you're immediately going to have another reduction that occurs here, right? And when this occurs, you then are going to have an additional hydrogen that has been added, and so you'll have something that looks like this. Now at this point, we need to, so the hydrogens are no longer decent leaving groups like the chlorine was. So at this point, we are left with the option of protonating this and finishing the reaction. So this, after your reductions are done, this is where the H3O plus comes in. We would grab a proton, okay, we would go over here, and then you would have a primary alcohol as your result. So this CH2 is due to this CH2 right here, right? And then the O- has become OH. So we can reduce, similar to aldehydes, ketones, right, esters, carboxylic acids, we can reduce acid chlorides using 2 rounds of lithium aluminum hydride and get them down to primary alcohols. So very useful reaction if you're looking to turn your acid chloride into an alcohol functional group, and then you could go from there. So very similar in the mechanistic pathway is the addition of a Grignard reagent. So again, on the channel, if you take a look, I do have lectures on Grignard reagents, and you would probably find that in with the alcohols chapter, because we use ketones and aldehydes in order to create, we use the Grignard with those in order to create alcohols. So if I wanted to do this, I would have my acid chloride, and then instead of the hydride this time, I would have whatever my Grignard reagent is, right? So we'll just use methyl magnesium bromide, a very simplistic example, and H3O plus. Again, you're really looking at doing this 2 times when you're working with this. So in this case, the CH3 acts as the nucleophile, and I come down to my tetrahedral intermediate, got the O- up here, right? I've now added a CH3 group. I have the chlorine. The chlorine will leave. This will seal itself back up. And then what I end up with, instead of an aldehyde intermediate, this time I have another stable intermediate, which would be a ketone. So with my ketone, I am now going to have another Grignard present, and we know that Grignards react with ketones. That's how we first initially learned Grignards, was aldehydes and ketones. So this would come in, make another attack on the ketone. Again, you would not be able to stop this or isolate at this ketone portion. You would continue on, and when you continue on, you're going to end up with the regular, right, intermediate that you would find for a ketone that's undergone a Grignard, which would look like this. Okay, you would have the magnesium bromine complex here. We can also add that back in over here. That would be stabilizing this portionality in the intermediate. And then again, after you're done all of your Grignard, just like with the hydrides, you can at that point start utilizing the H3O+. And when you utilize that, you grab the acidic proton, that goes to form water, and you end up with, as you would expect from a ketone, a tertiary alcohol. So at the end of the day, acid chlorides will undergo 2 Grignard rounds. First one takes it to a ketone, second one will take it over to a tertiary alcohol. So that is how we deal with Grignards when we have acid chlorides. So the last reaction that I just wanted to present here, that sometimes undergraduate textbooks will present this, sometimes they won't, but I just wanted to include it in case, is that you can use a Gilman reagent with acid chlorides. So you have R, C double bond O, Cl, right? And then the Gilman reagent is a reagent that is a what's called a lithium cuprate. So it's a lithium copper reagent, and then that copper is coupled with 2 R groups. So when you get ready to do this, it's actually lithium plus and Cu minus. So it's the copper that's going to end up coming in and attacking here. So the copper will attack, and similar to all the other examples that I've seen so far, when this occurs, I've got the chlorine. We know the chlorine's going to leave. Okay, so I've got R and R here. This will come back down. The chlorine will leave. And then I'm left with an intermediate here. This isn't the final compound, of a carbonyl that's got the group like this. Okay, so it turns out, in order to finish this, what really occurs is that there's a switch where the copper will leave and one of the 2 R groups, and they usually are kept the same in these Gilman, and that's spelled Gilman, okay, reagents. So what I really will end up with here is a ketone, right, where this R group comes from this, and then one of the other R groups was whatever this was. And then, of course, as a side product, I end up with CuR, and that's just the leftover remnants of the Gilman reagent. All right? So we now can create primary alcohols using reduction of acid chlorides. We could create tertiary alcohols using Grignard reactions with acid chlorides. And finally, we can create ketones using a Gilman reagent with acid chlorides. So that pretty much sums up. It's certainly not an exhaustive list, but most of the things that you would come across in an organic chemistry 2 sort of undergraduate lecture setting have now been covered as far as acid chlorides go. So please remember to like the video if you found it helpful, and you can comment. I'll be happy to get back to any questions, and people sometimes they leave suggestions. I try to tend to those in future videos. And sometimes people just leave comments, which gives me motivation to keep going if I know it's helping you guys. Please remember to subscribe if you like the content. That helps to support the channel. And check out our Udemy courses, which I'm going to be promoting at most of the ends of the videos here. That's a great way to help support me. It's less than the cost of a tutoring lesson or a pizza, and you get access to an entire chapter of content with my own PDF notes. So thank you for learning with us, and I will see you guys next time.